Well, welcome. Thanks for coming to this, the last session today. My name is Matt Milner, and I split my time between doing consulting for clients on cloud and connected systems technology. So I've done a lot of work with BizTalk, with WCF, message queuing, Windows Azure. And then the other part of the time I spend as a Pluralsight author, so writing courses about all those fun technologies that I go out and work with clients on. How many of you have heard of Pluralsight? Oh, it's so good to see. A couple of years ago, maybe a few hands would go up. Awesome. How many of you have a Pluralsight subscription? Okay, keep your hands up. If you don't have your hand up, look around at your mates. Ask them afterwards, and then stop up here and get a free trial card from me, because they'll probably tell you why you want it, and you can get a month and try it out. If you've got a development staff that you work with, stop down and talk to Eric or Aaron at the booth, and they can tell you about all the amazing salesy, dealsy kind of stuff they can do for you and tools and things like that. Anybody know what, I don't even know if I can pronounce that. Anybody know what Ghana trophy is? I'd be really surprised if somebody probably does. Growing something. Look at that. Just looking at the words, right? Growing beards. So I have to put up a number of different pictures because you'll never recognize me. It's I see people in the hallway here and I say hi, and then I say my name, and then I wait a few seconds, and then they do this. So I figured, you should probably just remember my name because I'll never look the same. I may or may not have hair. I may or may not have facial hair. It's a grab bag. But there's also my contact details. Those don't change nearly as frequently as my facial hair does. So my goal today is to talk about brokered messaging, right? Sending messages through a broker. And part of this then is going to be, okay, why do we want to do that, and what the heck does that mean? And then we'll look at some specific technologies. We'll see some options out there for you in terms of what you can use to implement this type of messaging. And we'll look at some of the trade-offs and the different things they provide. And we'll finish out by looking in detail at some of the different messaging patterns that you can implement using these technologies. Now, what's not stated there, but I probably should state, my goal is not to do zero to expert on any one particular technology. My goal is really to talk about brokered messaging in general, but give you a flavor of what the different tools are and what they can do, show you some of those features, and then you can go after and drill down into the ones that sound like they make sense to you. So, what's a broker? We talk about brokered messaging. When you think of a broker outside of our technology developer space, what do you think of? Stocks? Insurance? Maybe real estate. In the States we call them real estate agents, but some people call them a broker, right, or a broker dealer. And what does a broker do for you in terms of stocks?
Makes the deal.
Yeah, it makes the deal, right? And usually you say, hey, I want you to make this deal, and then he goes and does the deal for you, right? And they provide that middleman, right, or the intermediary. Now, what else might they do for you? If you've got a broker, right, and you want to make a deal, sometimes you'd say, I want to buy 1,000 pounds of this stock. But you might also say, you know what? When the stock hits a certain level, right, I want to buy a certain amount, right? I want to have some rules around these things. I want to tell you up front, right, some parameters, and then I want you to go and be my broker and deal with that for me. When I think about real estate, I don't want to have to call every person in every house, or flat that looks interesting to me. I don't want to let the broker do that, right? I want to talk to one person. I want to say, hey, here's what I'm interested in, right? And put that message out. You go figure things out for me, so that I don't spend my time just sitting on the phone all the time. So a broker is going to provide this middleman or this intermediary for us and provide some set of features and functionality, right? Some things that we want from them. When we think about messaging, right, in an application sense, really talking about taking some set of data, right, and passing it usually across a network boundary, but often across at least process boundaries or application boundaries. Right? Sometimes that message is just data. It's just a packet of data I want to deliver somewhere. Sometimes it's more of a command. I want to send you a request, right, that not only has some data along with it, but I'm actually asking you to do something on my behalf. Right? Here's an order, I want you to process it, I want you to cancel it, I want you to go in and update these things, right? So we have these messages that we want to send across. Well, if we didn't do brokering, what are some options for communicating from one application to another? What might we do? What do you do today?
RPC.
What's that?
RPC.
RPC? Yeah. Corva or DCOM or COM or, I can't say WCF, that's not supposed to be the RPC, right? Even though it ends up being treated that way a lot. Web services. Lots of folks now using HTTP and just web APIs. But what are some of the problems with those? What happens when you go to use RPC or you go to use even WCF or a web service or a web API? What are some of the issues you run into? What's that?
Configuration.
Configuration, yeah. You're thinking WCF, aren't you? Configuration, setting it all up.
Transactions.
Transactions, right? You want to be able to do transactions. A lot of times that becomes complex.
Receiver has to be available.
Yeah. He's thinking broker messaging talk. What's he looking for? Right? The receiver's got to be available. Big one.
Eventual consistency.
All right, eventual consistency. Yeah. So when we think about these, I'll start with the receiver's got to be available. What are some of the reasons they might not be available?
Too busy.
Too busy, right? Which also goes to the scalability. If I start hammering on that server, if I start getting a lot of load and I start hammering on it, it may just get too busy. It can't accept messages anymore. Or if the server goes down, right? And I got to have a connection. So we broker messages in a lot of cases to deal with these types of issues. Right? We don't have to worry in some cases that the server is even available right now. Right? Somebody mentioned available or eventual consistency, right? I'm not worried if the server is available right now, as long as I have some guarantees that eventually my message is going to get there and get processed. I want to be able to scale. I don't want to worry that if I get a flood of things coming in and I bombard my server with these requests, that the server's just going to fall over. Right? It may just be really, really slow, but a lot of times we've seen the back end it dies. Right? You overwhelm it and it just goes down. So I want to be able to broker these messages. Right? I want to be able to avoid those things. For connectivity, I want to be able to send a message and let some other system, right? I don't want to have to think about this too much. I want to have some other system in a lot of cases deal with eventually delivering that over to the end receiver. And yes, I want some management on that. I want to be able to see what's going on there. Obviously, I'm going to want to know for that eventual consistency, hey, did it not get there? Right? Did it not get there when I expected? For the scalability, I want to be able to take in as much information as possible, as many requests. Right? This is often the case with online commerce. When you go out today on a big site and you place an order, what do they tell you after you hit submit? What do they come back with? We got your order. Right? Here's some number that we generated with some algorithm that we'll probably put a patent on in the U.S. Patent Office, because that's what e-commerce sites do. We got your order. And then at some later point, you get that email confirmation, right? Or some other kind of asynchronous model, you find out, yep, hey, here's another kind of notification to make you feel good about it. It's not just a number. Here's the actual information about your order so that you feel good that we actually did capture all those details and we got what you wanted. So we want to have these systems that allow us to do these things. So on a high level then, when we talk about brokering messages, we've got a few key concepts we're going to use and terms that I'm going to use. One is a queue, right? Which we're all developers probably. We know what a queue is, right? Messaging queues, put a message in, take messages out. Different systems, those queues are going to have different capabilities, different features around them, but the general concept of I'm going to queue some data in there and later I'm going to read it on. But we also have this notion at a little bit higher level of a topic or an exchange. Right? Where a queue often is implemented as some sort of a physical storage for these messages, a topic is really more of a conceptual idea. Right? I have some message that I want to broker, right? And I have this kind of rendezvous point. I say, you know what? I have a particular topic, or I have a particular set of messages that are kind of related. I'm going to, excuse me, I'm going to send them to this topic, and then it's going to really do a lot of that work of the brokering. Right? It's not just going to be a simple message goes on a queue, comes off a queue. Now I might do some things around routing those messages, around filtering those things. Right? Just like I wanted my broker to do for me in real life, I want this thing to do that. And then of course we've got the publisher and the consumer. Right? Somebody's going to put a message in here or broker the message in, and then we're going to have one or more apps or consumers that are interested in pulling that out. So the technologies we're going to look at today include some on-premise technologies, RabbitMQ. Anybody go to the session earlier today? I saw that there was one. Couple? Good. I'll pick on you guys later and answer questions. We got Microsoft Message Queue, Microsoft's Windows-based message queuing option. And then Service Bus, which I'll come back to in a second. Now, in the cloud, both Amazon and Microsoft, kind of big players here, have their messaging technologies, of brokered messaging, with the Azure Service Bus, and Amazon has their simple queuing service. Now, there's others that I've left off here. IBM, it's probably under the WebSphere brand, as everything is. These days have their MQ series. You know of other cloud queuing systems? I don't remember if Google has one. I'm sure they have something they invented themselves. But these are the cloud versions of these things. And we'll talk about why that is important and kind of what that enables. But what Microsoft is doing a lot these days with their cloud technologies like Service Bus is they do all this work. They release every 6 weeks or 3 months or some actual cadence that we really appreciate with all these new features. And then every so often they take those features and they pull them back on the Windows Server. So today they have I'm sure the name will change this week, the Windows Azure Service Bus for Windows, or something completely confusing. Right? It's essentially the same functionality, but something you can run on your own servers with Windows and with SQL as the backend. So these are a couple of the different technologies that we're going to look at today. Let's come back and just look at a quick example here. Go away. So this is just the standard computer management in Windows. And I've got Microsoft Message Queuing installed on here. And you can see that I have this notion of a queue called orders in here, and we've got the notion of messages, so fairly straightforward. We look at that, we'll see that we can provide different options with this. Right? I mentioned that while the concept of a queue is fairly straightforward and simple, the different implementations are going to provide you with different options around what that queue really means. So for example, with MSMQ, you can choose to have transactions. Somebody mentioned the difficulty with transactions. This allows me then to make sure that operations against this queue, whether I'm writing or reading things from it, right, are all part of the transaction, either local or distributed, right, and that those messages, right, are part of that transaction. So if I'm trying to read them off and the transaction rolls back, they stay on the queue. If I'm trying to write them to the queue and the transaction rolls back, then they don't get written to the queue. They're not visible or available for anybody to read those. Let me just run a couple little apps I've got here for you so we can see what they do, and then we'll take a look at the implementation. So I've got just a simple app here. I'm a back-end guy, so no WPF or Windows 8 application here. I'm just going to do a single message over to MSMQ. And I don't have my receiver running. There's no application currently that's out there running to get that message, and that's that notion that I don't really care if the application's available. Right? I just want to get the message out there for it. And so if we go and refresh, of course we can see the message there. And we've got the information. It's binary, so the data is not very readable in this particular case. But we've got that message out there on the queue. And then we come along with our receiver. Say I want to receive a single message from MSMQ. And now I've got that message on. So if we look at this, the programming model is pretty simple. We've got this send message. I'm working with these small screens. And so you may do this differently. This is demo stuff, but I'm making sure that the queue actually exists before I go out and start trying to send messages to it. So I set that up. Often you'd have an installer program that would do that for you, so you don't have to muddy up your code with that. But the programming model for these things is really, in almost all cases, pretty straightforward. Right? I'm going to create some representation of the queue that I'm going after with an address. I'm going to maybe set some properties on the queue or on the message or on how I want it to be handled, and then I'm going to send the message. Now, you notice here I'm passing in this binary message formatter. We're going to write data. In this case, it was a simple string. Right? But we can also be sending objects to these queues. And so we've got to have some way, obviously, to be able to store those things out. For some of the technologies we'll look at, that's a byte array, right? Just very simple, it's got to be a byte array. For MSMQ, you've got options. Right? Binary, XML, there's even an ActiveX formatter in there that you can use if you want to be nostalgic. Formatting the thing out to the queue in some way so that it can be stored. Now, if I write it in there using the binary message formatter, that means that when I read it out, I have to use the binary message formatter, right? The XML message formatter is not going to work so well. If you've done WCF or other things, that'll make sense, just like the binary. So, fairly straightforward, right? And we're not limited to just sending that one over there, right? Obviously, we can send over a bunch of messages. This is where we start looking at, if I pull up the queue, right? Now, our system's getting busy, right? We're sending and sending and sending, but the only thing that needs to keep up is the message queuing. Right? Take that data, stick it on the queue, control returns to the client, and I can take more orders. So now I've got all this data that's queued up, and as I go out and run my receiver, it goes through and starts processing, a little bit of fake processing time, and eventually gets those things cleared off. So when you think about that, right, that notion of taking the orders or really building this out to scale, that's what we want, right? We want to be able to say, we get to draw. Drawn yet. So let's say we've got our back-end services, and maybe we even have two of these things together, working as a cluster maybe. We've got that queue out there. And today we've got two web servers, and they're both writing over the queue. That's great. These guys can pull that stuff off. But you want to be able to scale these things separately. You want to be able to say, hey, gosh, you know what? The web traffic's really picking up. We need to scale this out. Whoa, I don't know what happened to that web server. We want to be able to scale this out, and maybe we can get away with just that. We provision more web servers. If we're in the cloud, it's really simple. If we're on premise, and maybe we got to go bug somebody. But we've got these servers now, and now we've got more and more data coming in. But maybe these two are keeping up. Maybe this is just at peak loads, and we get stuff queued up in here, but eventually they catch up. But at some point we might decide, nope, our product is going like gangbusters, right? We want to be able to add one more in here. So building that out enables us to scale the pieces that matter, right? Scale the pieces that we need to, and not tile those things together. Now, what's something that's implied, but I haven't really said yet about these messaging patterns? We're talking about orders and going to these back-end services.
There's only one instance.
One instance of? Yeah, well, both. Message and the queue, right? I'm assuming that maybe I just have one queue. So we'll look at it a little bit later. We might have some partitioning that we want to do. But also that right now, it's one way. That's one of the things about brokered messaging, right? We don't want to sit and wait. We want to be able to send those messages across with those guarantees. But in most cases, we're not going to sit and wait. Somebody mentioned RPC earlier. It's technically possible to mimic some, synchronous over asynchronous models with this stuff. but generally not provided as guidance. So we have MSMQ. We also have RabbitMQ. I want to just talk a little bit about these two. These are kind of the primary on-premise, and Rabbit arguably is getting more and more popular, maybe getting used even more, because Microsoft themselves do a horrible job of talking about and documenting MSMQ. But RabbitMQ is freely available. It's got clients and servers that you can run on Linux, on Windows. You've got .NET, you've got Java. There are other clients out there in Python, and what's the other one? Let me see what the other one. There was Scala and Groovy and all sorts of stuff. Clojure, Ruby, whatever language you can think of, they probably have somebody writing a client for that. And so one of the big differences, obviously, is MSMQ is going to run on Windows. All right, if you're a Windows shop, it's there. It's built into the operating system. It's a feature you turn on. If you're not a Windows shop, then Rabbit is a great alternative. Rabbit also will run on multiple systems. So maybe you're an ISV or you create packaged software and you need to use queuing. Then Rabbit's going to allow you to be able to go out and target multiple operating systems. Be able to go out and run on different systems. Have the server running on a Linux server and have the clients be Windows or some other cloud. Now, there's some other differences that we'll get into. Anybody notice this piece here? How many of you write Erlang today? Not one? That was the thing that jumped out at me. When you go to install Rabbit, for example, you go to install on Windows. Oops, that's not what I want. If you go to install this on Windows, it pulls up the guide and it tells you, hey, you know what? The first thing you have to do is go install Erlang on your server. So it uses and depends on Erlang. So if you're going to go deploy this, you're going to have to make sure that you've got a way to package up and deploy that as well, which from the sound of it, you may not already have on your servers today. I didn't. Right. So if we look then at the Rabbit model, it's similar. Right? It's got just different names for things. We're going to have to create a connection factory. From that, we're going to get a channel. And then here, again, just like in my other code, I'm just making sure that queue exists, right? So you wouldn't necessarily need to do this in your code. You could script that out ahead of time, but I'm making sure that queue exists. And then I just do a publish to some address, some queue name, right, with that data. Now you'll notice here, I'm actually responsible for serializing this. So I've just got a helper class here that's going to take my message, whatever it is, this object that comes in. It's going to serialize that out to a byte array because that's the API that I have for using this in Rabbit. Right? I'm responsible for creating that byte array. Whereas with MSMQ and some of the other ones, all right, there's default formatters, there's pieces in there that you plug in. And there may be some other options here as well for Rabbit. So when we want a model like that, it's really pretty straightforward for us to run these things. So if we go out now, I've got my receiver running here. Close some of these other things down. What if we have another one? We've got two services now that are running and receiving messages. So let's say we want to receive multiple messages from Rabbit. And over here then we can go and send multiple messages to Rabbit. There we go. Oh, I didn't do it fast enough. I have a timeout in there and I'm not fast enough for my timeout. Let's do this. We'll go over here, we'll send messages. Now we've got 10 messages sitting there. So what's going on? I gotta keep you awake in the afternoon. Live debugging with no code. What do you think is going on here?
The queue running on one thread.
A queue running on one thread? It could be. Let's go and look at our receiver. You can see here we do the same thing. We set that up, and now we have this consumer out here. This is the API for receiving items off of there. And we go to that channel or that queue and basically say, all right, I want to do a basic consume, essentially passing in something that will get called back so that it'll get access to the data. And then we walk through that data. So we have these competing consumers out there, but they may have some, as you said, some ideas about how they're going to dequeue those things, right?
Is it being greedy?
They're being greedy, exactly. Let's go out here. So here we have this receive multiple messages, and we should be using this basic quality of service. We should be getting out there now and telling it, hey, look, I want you to go out and these numbers, if you look, one's the prefetch and one is the size and the prefetch count. So you have the ability to tell your client how to behave in those scenarios, right? Stop being greedy, play nice. I'm going to have multiple receivers coming in and acting on this queue, so I don't want you to try and use all those things up. Which begs the question, if I have that in there.
Did you fan out the messages?
No, because I actually want them to go onto a queue, and I want both of them to come in and compete for those off that same queue. That's a good question, though. Let's do this. Let's just restart those real quick. All right, so receiver. We got our sender. Try typing in the right thing here, so. Multiple. There we go. So the catch was I need to have them both set up and listening, right? And they need to be on that queue and listening because they're competing, right? And so they're both in there and active in this case with Rabbit. And then as the messages go in, they're getting routed over to those things. So one of them gets some and the other one gets the others. And you can tweak those things as well. So the different systems behave a little differently, right? If you fired up another one of these and pointed at the queue, right, it may be some time before it starts getting messages out of the pool, and you can tune those parameters around pulling those out. So that's that model there, where I've got messages going on the queue, and then I have multiple processes then that can pull those off and use the CPU and use the memory to handle those messages. So when we use brokering, we can do the scalability, right? We've got the eventual delivery in some cases. We've got the option with these systems to turn on durability. So when I say durability, what I mean is I want the system to actually store the message in a durable fashion. I want to write it to disk, whether that's in a database or a file somehow. I want to write it to disk. What does that give me? If I do durability, what's that going to give me as a benefit?
Resilience.
What's that?
Resilience.
Resilience, yeah. The server goes down or the service crashes. I don't lose that memory. What's the trade-off maybe? Performance, right? Things will go a lot faster if I don't have time to write this thing to disk. So Because those are options usually at that queue level, right, or at the message level in some cases, where you can say, look, this message or these messages going through this queue, it's okay if I lose some in those rare cases. If it's the stock deal, maybe not so much. You might not want to do that. But depending on what those messages are, if you're doing logging or doing other things through queues, then it might be okay. So you can turn those things on. Now I want to talk a little bit about the eventual delivery. Go back and look at MSMQ. This is one place where I really like the way that MSMQ does this out of the box. This is all running on one machine, because that's how I set it up, and I've got my little private queue here, this orders queue. But if we're doing something like this, we're writing these things. I'll switch. If I've got my client computer over here, my server, my web server, and I've got my processing server over here, if the queue is over here, and the server's down, it's not really giving me any of those confidences that I really wanted, right? I still have all those issues of, well, if I can't connect to that queue to write the message, then I'm in trouble. And so what MSMQ does, when you send a message, you see this little outgoing queues node here, is when you write the message to the queue, it actually gets written here. It gets persistent, it's durable, it gets written into the disk, it gets written here. And at that point, then, MSMQ kind of takes over. I've written my message to the API and it takes over. My app can go away, my app can shut down, whatever needs to happen. As long as the MSMQ service is running, it then is going to take care of all those next steps, and making sure that gets delivered over to the other side, handling the failures and other things that come along with it. So this really provides a lot of those connectivity issues. If you're working with Rabbit, they do have the notion of clustering. So you can do something like have a couple of Rabbit servers out there to help with the availability so that they're not down. You could do something similar with MSMQ as well. So you could have two servers and they could be in a cluster so that no matter what, if one goes down, the other one comes up. You can do those sorts of things as well. But this really does provide you not only that failure, but what's another scenario where you might want to have things queued up on the local machine?
If you're working offline?
Yeah, if you're working offline, you've got remote field workers, right? They're putting in orders, they're putting in things like that. You want to queue them up. When they plug in, when they're online, MSMQ will take care of delivering those messages over for you to the back end.
Just a question on that.
Yep.
Are you talking about actually the queue being distributed across two machines, or the fact that the queue is sitting on the local machine and the receiver pulls it off the local machine?
Which piece? When you cluster, or just this part right here?
With MSMQ, you said you write the queue locally, and
Yep.
MSMQ handles the delivery to the other side. Are you talking about, because it can't do remote transactional reads, can it? So if that
Yeah,
was
in MSMQ4, it can't.
Yeah, I was going to say, it can't now. It used to be the case in previous versions that it couldn't. Yeah. But it could always do transactional writes. So it was able to take this message, make sure it got delivered to that other side, and then leave that at the local queue here.
Not that you want to do remote transaction.
But you can. So many other things. So yeah, so it'll take care of making sure that that gets delivered over there, right? There's some underlying protocol things going on there in terms of acknowledgments between the servers that happens. With the cluster, in both cases, obviously the service might be running on either of these nodes. But if you're doing durable messaging, if you're going to have things that in that queue, in the queue itself, if there's anything stored, you've got to have shared disk, obviously, between those, like you would with most clustering solutions, where that shared data can be persisted. Other questions? Before I get into messaging patterns, I'm going to jump back to this idea here that we've got these things, right? And we've got our queuing. We've talked about a couple different scenarios where we might be able to use this with remote workers or with servers in the same environment. But what happens when that occasionally connected client is a mobile device? Or that client that you want to be able to read things off of your queue doesn't happen to be in your data center. How many of you have systems today that have to communicate with partner systems, customers or other vendors? What do you use today to connect your environment to theirs? What's that? Using MSMQ across?
VPN tunnel.
There we go. That was what I was looking for. There's the VPN tunnel, right? So they're connected together. Anybody using anything besides VPN to connect it to? You ever have any problems with the VPN? You said no. I would want to find out who set it up for you because that's almost always the case, right? There's always troubles with those VPNs, right? And usually what happens then is what's on your end. No, you changed something. No, you changed something. And so, one of the things that Microsoft and Amazon have kind of brought to the table with the cloud is the idea of connectivity through brokers, right? Through something out of the cloud. And the benefit here is that we don't have to have the VPN in most cases. At the end, I'm going to do a giveaway and take my lovely drawings on the picture. So, you've got your environment over here, with all of your NAT and firewalls and all that good stuff hopefully turned on. And then you've got your customer over here who needs to be able to receive these messages. Well, we already know that a VPN connection might have issues. We might have connectivity problems, which is kind of killing our whole notion that we want to have connectivity and we don't want to deal with those issues. Maybe the queuing system will queue those things up for us and send them eventually. That would be good. But what if you can't do that VPN? And that's where having something out here in the cloud, you're on the cloud, and they always have to have lightning bolt through it. I should have taken a drawing. So we have something out here in the cloud. Well, that means this guy no longer has to directly come into your environment. This person maybe just needs to come out here. And we just need to come out here. And these are outbound calls. So now if I've got a queue out here, my application could write to this queue out in Azure, and if I get it sent there, I know I've got some durability. Or if I put it in an Amazon simple queuing service queue, and then my customer, as they can connect, if they have connectivity issues or when they come in, they can come in and they can monitor those queues, and they can pull messages off of those queues. Now, what kinds of questions does that raise for you about all those things we talked about, the durability, scalability, all those things? Any concerns that pop up as you think about doing something like that? Security?
Trust.
And trust. When we talk about trust, are we talking about who? The cloud. I don't trust the cloud. That might, yep. Is it the cloud or is it the vendor or both? Both. Yeah. So there's this with the scary lightning bolt, right? That's always a question. And then there's the, right, Microsoft, Amazon, right? Do we trust them with our data? And that's absolutely an issue, right? That's one of the things that always comes up is, okay, well now I want to have this whole durable messaging store, but now it's in your data center, right? And the VPN might start looking pretty good to some of your executives and some of your team, right? So that absolutely comes into play, right? The security implications and some of the business implications of that. What about some of the other things you mentioned? What about transactions?
Well, there are any.
There you go. Hopefully there aren't any between you and Microsoft Data Center. Microsoft and Amazon are both thankfully kind of smart enough to say, we're not going to let you take transactions on our resources on the back end, especially when we're trying to share those and scale them with thousands of customers. So what can we do? Let's look at this right here. So I'm writing a message to this queue, and I want a transaction. So I might know that I've written it there, but I'm going to lose some of that transactional capability I'd have if I was writing to a local resource. What about from the read perspective? What can we do? We can't do a transaction, but what can we do there to guarantee that we don't lose that message, or that we're able to successfully receive it.
Or you could peak it, I guess, rather than put it.
Yeah, exactly. So come over here, say, you know what, I want to peek, and I want to lock it. I want to peek that message out there, I want to get the data, but I also want to kind of mark it as locked, that I'm using it. So I get that message back in here, I do my processing, and if everything succeeds, right, then I come back here and do a delete. So that enables me to get the data, everything succeeds, it gets destroyed, and nobody else picks that up. Right? We have that competing consumers idea. That message is locked for any other listener out there. They're not going to be able to pick that up until I unlock it. Now, what's a potential pitfall if I lock it and then my service goes down? It stays locked, right? So the lock, right, is time-based, right? We lock it for a certain amount of time. We come back and delete it in that time. Great. If we don't, eventually that lock releases and some other consumer can come in and pick it up. Right? So if we die, right, if our service goes down and can't finish processing that message, then the service bus is going to allow another client to come in eventually and pull that message off so it doesn't get just stuck on the queue.
If you set something to lose connection, that'll drop the lock. So if your service does go down sometime,
Oh, yeah, this service goes down?
so basically you lose that service, you lose the connection to keep.
Yep.
Can you set something to actually drop the lock?
In some cases, yeah, it would depend on how gracefully your service went down. If the connection was just severed, no. But if the service is actually going down and everything gets kind of cleaned up in your client code, it would notify the server.
I mean, if you took a SQL server or something like that, you've got a transaction on that.
Right.
If you lose connection to the database or anything goes down, that will break.
Right, yeah, because eventually SQL knows that that connection was broken, and you've got to have some way to do that here. But if you're doing, with the peek and lock, you're kind of doing an HTTP request, getting that back, and then you're disconnected. So unless the service kind of fails gracefully and can ping back and say, I'm dying, I didn't get that, then it would be based on the lock time. Yeah, and a lot of it comes down to those connection-based or disconnected models, and under the covers that primarily uses HTTP.
Does that mean that if your processing time slows down to approximately the time of the lock, that you could process the transaction twice?
Yep. Yeah, exactly right. So if I take longer, if I say, hey, lock this for 30 seconds, and then it takes my process a minute, because things are slowing down, chances are pretty good that another consumer that's out there, if I've got multiple consumers, that thing's going to be available to be picked up by them. Or if I'm doing even multi-threaded on my one consumer, if I'm pulling things in multiple threads, that could be unlocked. So there definitely, as you think about this, there's definite paradigm shifts, right? And ideas that you have to think about. If I'm doing it in the cloud, or if I'm doing it on premise, what are some of the issues about how I interact with these messages to make sure that I get the consistency, I get the durability and the scalability.
Excuse me?
Yeah.
Are there clients available for mobile platforms that we run on mobile platforms?
It's a good question. Are there clients for mobile platforms?
Say you have not
Windows CE.
version of your app that you're running on mobile.
Yeah. I don't know for Rabbit. I haven't looked into mobile for that. MSMQ, nothing that anybody hopefully is running today. There may have been some clients on old Windows CE devices. So it's possible that for some of the handheld devices, the ruggedized handheld devices, they may still be running CE. And for Service Bus, there are libraries that you can get in .NET and other languages. And some of those will probably run on the various devices. I'd have to look. I'd have to look at the particular client libraries and how they're stamped, for example, for .NET, whether they'd run on Windows Phone. But under the covers, there's message queuing aside and whatever protocol they're using. Service Bus can run on HTTP, so you can do a lot of these things with REST API versus an HTTP library. And so, for example, the .NET libraries are really wrappers over that, using either WCF or just plain .NET objects where they just wrap those calls for you. RabbitMQ is using AMQP, the messaging protocol is kind of being standardized and shared. And so that's one of those things where, again, if you have a client that can talk that protocol, it would work. And Service Bus actually has recently introduced support for AMQP as well. So on the server side, they can communicate over AMQP 1.0. So both Rabbit and the Service Bus support that on the server side. They support 1.0. The clients, however, the Rabbit clients today are still using some of the older versions of AMQP. So eventually, hopefully, they'll get up to 1.0 as well. There may be some betas out there, some open source versions, but the supported client today does not quite support 1.0. Yeah, and you know the Service Bus, right, that was one of the things with the cloud was the mobile clients. They occasionally connect with clients, and that's one of the reasons a lot of that is surfaced through HTTP, because whether you have a library or not, ultimately, if it's a device and it can connect, it's going to be able to do some things over HTTP. Somebody mentioned security. I'll just touch on it briefly. All of these things have the notion of security, obviously. The idea of some sort of credentials that you can use to lock down certain aspects of it, certainly the management, whether you can create a queue or not, but also who can send, who can receive messages on those things. So Rabbit has this notion of creating users and user credentials. MSMQ can use, not surprisingly, Active Directory, but it can also use certificates, if you want to use certificates for the queues to protect them. The Azure Service Bus has a couple of different ways now that you can do that. One is through the notion of the access control service. When you spin up your Service Bus namespace, you actually get an access control service relay. And ultimately, today, that's getting used basically as a username password store, I think. It had all this promise about identity management, so I could log in with Yahoo of all things, or Google, or Microsoft account, and then those would all get transformed into one kind of identity. But that's all kind of shifting now more towards Windows Azure Active Directory. But on all these, again, you have the ability to say, hey, this is somebody with, if you have these credentials, you have these permissions, you can send messages to this queue, but you can't read them. Or you can read off of this queue, but you can't send. So, especially when you start talking about customers and partners sharing these queues, whether they're over a VPN or if you're talking about through the cloud, you want to be able to lock that down and say, look, these are messages coming to you. We're the only ones that are going to be sending messages to that queue. Right? We're the only ones that have the credentials to be able to put that data in there to give them some sense of hopefully security about that. Right? And these people are the only ones that can read off that queue. We don't want, if I put data into a queue for this customer, they're the only ones that can read that data off of that queue.
Just a quick question.
Yeah.
What's the encryption of the actual data flowing between the queues?
Depends on the implementation. Service Bus often will just use SSL. You can decide on the on MSMQ, you can set that up again on the messaging or the queue basis, whether or not that's protected. But it depends on the credentials you're using. So it can sign and encrypt those depending on the credentials that you're using. With the Service Bus as well, you're providing those credentials. So again, there's going to be some doing it over SSL usually, but also signed off with those credentials so that when it gets to the server, it can validate those things. So this is the lovely Windows Azure portal in all its blue and white glory. And out here, one of the many components in Azure is the Service Bus. And honestly, for me, as a messaging guy, it's one of the coolest ones, but I suppose I might be biased. But essentially what you can do in your Azure subscription is provision a Service Bus namespace. So I have this M3 brokered messaging. We go, I pull up the dashboard here. We can see I've got a number of different items underneath there. Now what it means to have this particular namespace here is if I go look at some connection information, 20. What you're going to see is that by declaring that namespace, I've really kind of registered and owned this particular DNS namespace. So it's called M3 brokered messaging. All right, so M3 brokered messaging.servicebus.windows.net. That's my DNS namespace. So from there, when I want to go out and create queues and topics and all those things, those are isolated under that namespace that I own. All right? And so all the access control and other things at that level, I get to manage and I get to work with. So somebody else can come along and create their own namespace. They have their own keys, their own permissions for that. But underneath this, then, I kind of own that structure. And so all of my naming just needs to be unique within there. And so we have the notion of queues out there. So I can have a queue out there with the simple orders. Go look at the configure. All of those kind of things that we've talked about show up out here. So the concept of the queue, again, similar, different functionality, but we have the notion of messages can expire. The service bus can actually manage duplicates. So if we send a message and there's some network issues, and maybe our client application thinks that the message didn't get through, or we didn't get back the HTTP response, or something happened, and the client resends it, well, they're going to be able to detect that. And so they'll, on the queue, you can have that detection history, and you can decide how long to watch for that. This is the default lock duration, 30 seconds. Again, you may want to change that based on the queue itself, or you may want to do that on a message level. You may want to say, you know what, this particular message, I know it's going to take a long time to process for this type of message, so I'm going to make sure the time to live is longer than the default. So one of the things we can do out here is we can go and certainly see the queues, and you can even see kind of an idea of how many items are in the queue. As you start getting volume through here, it's not going to be exact, but they do update periodically to let you know when things are out there. Now, if you're working in .NET, the whole idea is it shouldn't be much different for you than what you were doing with any other queuing. Right? Create a brokered message. Right? You can set properties on it, like I showed there. Create a client to talk to that queue and send that message. Right? Very simple API. Lots of stuff going on under the covers, but very simple for us just to create that message. And you'll notice that this is one of those cases where I just send in an object. As long as it's serializable, whatever this T type is, then it's going to be able to go out and serialize that and send it. Now this create from connection string, go look at our config. There's all that information. So it's got the base address. It knows where to start. And any time then that I start saying I want to interact with a queue or a topic or any kind of named entity, now it's got the base URL and it can work from there to resolve those things. And it's got my credentials.
So how did you configure your app to look at that queue?
How do I configure the app to look at that queue?
Yeah.
So in this case, I pass that in. I tell it what the queue name is. So I create from the connection string, put all in one line, these small resolutions. So there's the connection string, and then this is essentially the queue name. So if I want to receive off of that queue.
So you didn't connect to Azure and didn't populate the property file in that way?
No, good question. So I did go out to Azure and I went into that namespace there. And then right here it shows me the connection strings. So I just copied this right out of here. And so that gives me access to that whole namespace. In this case, because of the keys that I'm using in there, I have access to the entire namespace that's available to me. You can set up you can set up on those particular queues. For example, I can go in here on the configure, I can set up individual access policies here. So I can come in here and say this is my customer one access, and they can come in and they can listen on this queue, but they can't send anything or they can't manage the queue. And then here's their set of keys. So they've now got a keys that they can use. They can set up permissions. Right? I can give this to them and say, look, here's what you can use to connect to this queue and listen on it. I don't have to give them my credentials or give them overall access. It can just be specific to that particular queue that's available. And obviously, you can come in and periodically cycle through these. So have them go through and use the secondary key for, once they've switched, then you regenerate the primary and change those out as needed. So I'm going to send that out there, and I'm going to use, out here, as I said, we can't really see anything. There's an excellent tool called the Service Bus Explorer. That if you're going to do any work with this stuff, you're probably going to want to download, and hopefully you have a higher resolution monitor that can fit it. For some reason, it resizes when it's on a big monitor, but when it's on a small monitor, you can't resize the columns. But if we go look at the queue, oh, no, it's not even going to be. Scroll over. There we go. And refresh, I get that same information. I can see the active message count. But what's really helpful is you can go into the messages, and you can keep those messages and see what's out there. So if you need to, you can go and grab that thing and get all the data. And you can see, again, it took that object. If you can notice this whole underscore backing field business. All right, basically, the .NET serializer kicked in and used the auto-generated backing fields for my properties on that order and stored that stuff out there in this binary format. So as we look at some of these different patterns, I want to get into some that are a little more interesting. We talked about the multi-consumer, right, where we might have a competing sort of thing. But we also have that notion of publish and subscribe, right? I want to be able to take a message and publish it out there and not have it be a competition, right? I've actually got multiple consumers, right, consuming applications that need to get this message. So you think about maybe vendors, or customers, right? I need to send out a message, and I want them all to be able to receive it, right? Maybe it's a request for a quote from vendors, and I need to send it out and have them all respond, or I need to send something out to all my customers or certain customers. Right? And so I want to be able to publish one message and then have it go out to multiple places. Well, what's the problem if I just have a queue for that? Yeah, if I've got a queue and I write a message to it, how do I decide who's going to get it? And how do I know when everybody's gotten it that needs it? So, what would you do if you needed to send it out to multiple consumers? Yeah, you set up and say, you know what, I actually really need to end up sending it to multiple queues, right? So we have something that's actually going to kind of sit in front of the queues. For Rabbit, it's called an exchange. For Service Bus, it's called a topic. But the idea is similar. We're going to go out and we'll go look at the. Look at this. We have a similar model. We're going to go create a channel. But notice here, instead of a queue, we're declaring an exchange. We're saying, hey, if it doesn't already exist, create this thing called an exchange. And it's got a particular name that we passed in. And in this case, with Rabbit, we tell it what kind of exchange we want. If I pass messages to this exchange, I want it to fan out to all the subscribers. All right, everybody equally should get this message. And then I go through and I do a publish. And this time, these things are slightly reversed. If you look up here, right, I was basically calling an empty exchange and a queue name, and now I've reversed it. I'm saying pass it to the exchange without a queue. Now, the thing about publish subscribe is there might not be any subscribers. So I really am interested in who is subscribed to this, who's going to work with this. So we go to the Rabbit client here. Exchange, right? Same thing. We go through, and what we do on the receiving side then is we create a queue with no name. Just say, look, I don't really care what this queue is called. I just want you to create it. And then what I want you to do is I want you to bind it to that exchange. I want you to essentially subscribe to messages that come in on that exchange and let it know, hey, I'm interested. Right? Here's a queue. Doesn't matter really to me what it's called, but here's a queue that I've created. And I want you, anything that comes to that exchange, right, in this fan-out model, I want to get it. And then we go through and start pulling things off of that exchange.
How long does that binding live?
As long as that client is up, I believe. So if the client shuts down or your connection goes down, then you lose that binding. So we've got our receiver here, right? So I want to go over and receive on the exchange. And let's see what happens if I just do it for that one. Right, so I'm going to send this fan out to Rabbit. And we got it on that one. He was listening on the exchange. He got the message. But the other one didn't. So we come down here. What happens now? This one's restarted. Nobody's listening. What happens if I send to the exchange now? I'm sending it. Where's it going? I don't have any subscribers. The void, right? Or as my wife's doctor called it, third space. I can't figure out where something went. This made up space, right? It's just going to the void because it gets to that exchange, and the exchange says, well, who do I have that's interested in this? Who's my subscribers? Nobody. Right? So in that case, right, nobody's interested. I then can't send that anywhere, so I'm just going to drop a message.
Can you know that no one received it?
So
you can know there's no subscribers in advance.
I don't know. It's a good question. I will admit I'm not a Rabbit expert. There may be a way to find out on that particular exchange whether it didn't go anywhere.
Yes, you can.
You can. Okay, thank you. Is it a setting on the exchange?
This is a thing on the channel.
On the channel. Okay. Yeah, I figured there was. I just don't know where it is. Yeah, because you're going to want, in a lot of cases, as a sender, you're going to want to know that sort of thing. And so the same type of thing you can do, actually we pull up and look at a topic in Azure Service Bus. It's that same idea, right? I'm going to send to a topic, but the topic itself doesn't really have storage or a queue behind it. And so we have subscriptions. And so if we look at the topic, get it all to fit on this tiny screen. There's this check right here. So to your point, that's why I assumed Rabbit probably had that. The enable filtering messages before publishing, right? Letting the client know, hey, you're trying to publish this topic, nobody's subscribed, get an error back on the client. Right? So similar kinds of concepts when you go to publish to let you know that nobody was interested in that message. So that's kind of a generic model then where we have these subscribers that just say, yes, I want messages. But really, in a lot of cases, we're going to want to go beyond that and say, you know what, I want messages, but I want certain messages. I don't want everything that you send to that exchange. So maybe you're going to come in and you're going to post those requests for your vendors, right, for some sort of bid, but I only do government bids. Or I only do bids for you guys that are over a certain amount. You're crazy to work with, and I'm not going to bid on anything where I'm not going to make a lot of money. So we want to have the ability then to route those based on some sort of conditions, right? Based on some sort of criteria within the message. So again, we need that topic or that exchange that's going to allow us that central point to publish these things and some way to process those through. So with the topic, when we look at the subscriptions, we can certainly come in, I can create a new subscription, and let me call this all orders. And you'll notice that the filter here is just 1 equals 1, essentially true. Right? Every message that comes through, I want. We create that. But I also have this large orders and small orders. And so here, I'm looking at something called order total over 500 or order total under 500. So that's information that we've got to pass if we're doing this send from our client. So we're going to come in here. And essentially what we're doing is using that same brokered message, but we're also looking for any properties that we should attach to that, right? Essentially metadata or context for this data we're sending or this message we're sending. What properties do we want to tack onto that? So as we go do this send over to the message bus, we can pass in these properties. And we can say, hey, you know what? Here's just some additional metadata that I want you to tack onto that thing so that when it gets to the topic, I can use this information for routing. I can decide, with those subscriptions, where this should go. So here our order total is over 500, so this one, if we send it, should go to that, should go over to the large orders. Come to large orders, refresh, peek the messages, can't see over there. There's one from earlier today that I apparently didn't delete. And there's one that came over, and you can see there are those properties that were attached to the message that it's able to filter on. So a fairly rich filtering model. The filters are kind of a SQL syntax, actually, that allow you to do various comparisons or checks on those. And they are type aware, right? I passed in an int here, right, and did a filter on it, and that allowed me to do that type of comparison in terms of the greater than or less than. If I passed a string, this thing would get stuck, right? It would fail because it's not going to allow me to do a greater than, less than on a string that's numeric.
Doesn't that create logical coupling between both sides?
In what sense? I mean, it does provide this notion that, yeah, the consumer is dependent on the publisher providing those particular properties.
Well, if I'm a publisher, I'm saying, look, I'm just publishing my orders out.
Yep.
And then along comes a new subscriber that I've never heard about before, and they want to include some of that sort of filtering logic. In essence, what we're saying here is that unless I change my code to start putting those additional properties on the message, they're not going to be able to filter successfully.
Right.
That's what I mean by logical coupling. I
Yep.
change the code over here, get the code over there.
Yeah. Yeah, the subscribing side of it is very kind of metadata management portal driven, right? Where you just say, here's my subscription. But the publishing side is a little bit harder because if it's baked into your code, as you put the messages on, then it's a little bit harder.
Well, I mean, if you already knew that there was this concept of large orders and small orders,
Right.
then arguably you as a publisher would have just created a different message type and said, I'm publishing a large order or I'm publishing a small order, and would have been done with it.
Right. Yeah, so I think in some cases you would, you might have this set up in such a way where you'd say, you know what, I published these particular properties. And there are a number of things you could do in terms of the subscriptions, where you could potentially say, well, I already have this set of data, and so maybe it's not order total, it's the customer. I'm gonna forward that on to a different queue for them. So there are a few things you can do, but you're absolutely right. There's definitely a piece of, okay, I built it this way. These are the metadata properties that are available, and if somebody comes along and needs other metadata, then I got to step back at my publishing and see, how do I publish this message with the metadata they need to route? Now we should also have it in our all orders, of course, because that filter was every message should come through, and so we've got it over there as well. So it allows us with the subscriptions now to route it over to these different places. And the subscriptions, when you think about them, look at the small orders who don't have anything. Right? Those are essentially just queues. Right? They've got that same idea of storing the actual messages, being able to be read, pulling things off of those queues. But in this case, they've got the rules around what goes into that queue based on filtering through that topic. And with the Rabbit client, there's similar, although a little bit more maybe rudimentary kind of model, depending on how you like to write your data in there. If we go look at that piece, when you pass in the message, when you go send it to that exchange, you can pass in a string, right? And it's essentially almost like a namespace, right? It's a dot separated string, so you can say orders dot and a customer ID and something else. And then on the receiving side, you build your filter up either to match exactly, or you can use wildcards. All right, so just like the all filter on the service bus, you can just put in a hash and say, look, I want everything. I don't care what that string is. Or you can say, you know what, orders dot star. Anything that starts with this routing parameter, I want to get that as well. So they all kind of provide those sorts of functionality. MSMQ, trying to think of a polite way to say this. MSMQ is older, which isn't necessarily bad, but a lot of the kind of the publish, subscribe, the exchanges, the topics, all that stuff has really become a lot more popular and a lot more embedded in these systems. And so MSMQ has some things like that where you can do multicast. Right? So when the client sends it, it can go out to multiple queues. But without some work, it doesn't really have this concept of I want to be able to publish a message into something that's not necessarily a queue, right? This topic or exchange, and then configure or decide at the subscriber level who wants to get copies of those messages. So you can certainly build some of that stuff out yourself. So I'll just mention a couple of the things that are available in these. We talked a bit about durability, right? They all kind of provide that ability to save off the disk. There's also the notion of acknowledgements. Right? So if you want to send those messages over, you maybe don't want to do RPC, but you want to have the acknowledgements coming back. Right? So some of this is just the protocol underneath, right? MSMQ acknowledging that server B got the message from server A. You can also pull this up into your application layer and say, I want to get acknowledgements back. I want them to come back on this particular queue so that I can see them and process them. Likewise, we have the notion of failure handling. Right? What happens, I mentioned that case where I sent a message, I was trying to filter on an integer value being greater than or less than, but the type of the value I sent was a string. And so my message just got kind of stuck. Right? It picked a particular, it went through a topic and it just picked a particular default subscription to put it in, but it wasn't something that I could read. Same thing with MSMQ, with Rabbit. There's all sorts of cases where you may run into failure. And the common pattern then is to have what's known as a dead letter queue. So I go to send to the server. Eventual consistency means different things. How many of you eventual consistency means it's going to get there within a minute? What about an hour? Well, it takes a week, right? At some point, your business requirements are going to say, you know what, it's not okay that that message is still sitting in the queue. We know that you trust this is going to work, but it really needs to get there. Right? So all of these things have the notion of a time to live, right? How long is it acceptable for this message to be sitting out there in the queues? And they all also have that notion that if I hit that threshold, take that message out of the queue, right? Obviously, whatever's supposed to happen isn't going to. Pick it up and move it into a dead letter queue, right? Put it somewhere else that I can then monitor or watch and see that, here's a message that failed, right? Let me go figure out why, let me do something about it. As opposed to looking through a queue with maybe hundreds of thousands of messages and trying to find that one that's stuck there. Right? So they all have that notion that usually it's time to live or couldn't deliver it for some reason. So maybe with that MSMQ, that disconnected client, they put in a bunch of orders and then they packed their laptop away and then they went on vacation and they didn't come back for 2 weeks. And those orders never got through, right? So those are the kind of things where those might get shifted over to a dead layer. There are, I mentioned RPC as well. There are also the notion of response queues in a lot of these, right? So I send you a message, the application can respond back. We can correlate messages together if we need to and have IDs. Generally, I shy away from that because if I'm going to do RPC, I'll probably just do RPC instead of trying to do it over queues. But there are a lot of different messaging patterns you can do underneath there as well. So hopefully that was helpful in kind of getting a sense of the different patterns you can do, the different functionality of these messaging clients. We've got a little bit of time for questions. I'll stick around as long as you want. If you don't have a Pluralsight subscription, feel free to grab a card or take one for a colleague. And with that, I'll say thanks. Anybody have questions? Yeah.
Any scenarios where you can think this is not optimal, or it's other engineering things? Or there's always some use to that sort of.
Yeah, I think the first question usually for people is whether the one way is going to work in the car. That's kind of one of the big questions up front is, okay, can we architect this in such a way that one way is going to work? And in a lot of cases, if somebody's on a web page and you know, sending that message requires that you get a response back in a particular time to the user, it's generally not going to work, right? And there are other solutions in all these scenarios. Use WCF, use RPC, even with the cloud-based stuff. Right? We're looking at brokered messaging, but there's also a relay out there. Right? So even if you need all that great connectivity between environment stuff, you can do it real-time request response through the relay. So I think that's usually the biggest one that people run into. And the other usually just comes down to the technical issues of, we have thousands of laptops, we can't install queuing on them, those sorts of things.
The service buses, they can't pull in any messages.
It depends. There are different different modes that you can run in. So if it's HTTP, it does do an HTTP request out, and then they do some fancy stuff under the covers to try and do that. But ultimately, yeah, it's an HTTP connection, so it's going to have to go out and pull. There's also TCP, so it can actually have an open, active connection to pull those things down.
So you're receiving an event to say there's any message there.
Yeah, and usually, when you use it, especially using .NET, it's all kind of abstracted away, and you can use either the model I showed here with the brokered messages. You can use the WCF model, especially if you're doing the relays, and then your programming model is exactly the same as if you were sending it to a server in your environment. It's just I open a connection, or I do a receive, and
I believe size limits, I'm going to assume queues of this full meg fixed size or max size for a message.
Yep. Much smaller. Yeah, much smaller. Service bus and I think Amazon are both 64 KB. So they're intended for much smaller messages passing through.
S3 or whatever.
Yep. Yeah, and usually what you'll hear as advice is if you need to pass large data, well, of course, both Amazon and Microsoft have some sort of blob storage, right? And so the idea would be, hey, take that 3 meg file, 4 meg file, whatever it is, put it in storage, and then once it's there, send the message, right? And then the other side can pull it down and get that.
There are true queues, there's no way to cherry pick your way through, but let's say I wanted to get the certain amount of things, the most common type of a record, you wouldn't be able to take some statistics and then pick off those, or would you just use filtering for that?
Yeah, probably the easiest way would be to do the filtering up front so that those things of different types just get put out to different queues. So sending them to the exchange and just putting them out there, and then it's a lot easier to say, I just need to go pick these things for this process.
And you can work out the counts that it is queued up on all of those.
Yeah, it is usually the documentation and the recommendation will tell you it's not exact, but you can say, generally how many items are in this queue, is it 10, is it 1,000?
Yeah.
So you know, but 10 or 11, you might not get it quite right.
In queue series gives you a pointer to the queue, so you can actually walk through the queue and just like you would be. It's an interesting variation of FIFO, but
Right. First in, whichever one I want to have. Yeah. Yeah, and depending on, obviously the cloud model and the on-premise can be a little different. If you were connecting directly to the queue, they can do things like give you that pointer. You can certainly go in and grab particular messages. You can grab a particular sequence message and say, I want this one. And in fact, I don't know if this is true of all of them. There's a notion of session as well. So if you need to, I've got to pass 5 messages together as part of a unit. They all go together and they need to be processed in order. So you can create sessions. They all get a session ID that marks them as being related. They get a sequence number, and then the receiving side can pull those out. So you can do that with the service bus. You do it over MSNQ as well.
Priorities are in queue.
Yeah, messages can have priorities as well. So that as you go to, you just start popping them off. Again, first in, whichever one's important out. It's not necessarily that, but yeah, you can assign priorities in all the systems as well.
In the Service Bus Explorer,
Yep.
I noticed there was a setting that looked like maximum number of messages, but you had set 10.
Yeah.
Is that what I thought it was?
Yeah, I don't think it's what you thought it was. No, there's a maximum size for the queue. Yeah, it's the maximum delivery count. It has more to do with retries.
Okay.
No, it's not how many times it can be delivered. It's actually, if you go back to the, I think it's here. Yeah, the current size and max size. When you create the queue, you can give it, how big can the queue get total. So.
With the on-premise service, let's say you had 80 nodes and one dies. I found that it's difficult to sometimes find which one's not. But
Yeah, the hard part with the on-premise is they haven't given you as many of the nice management tools.
and it's difficult to find out anything because often it's zero and you don't know what often is
Yeah.
it is just a mishmash.
Yeah, because they have the portal and then they just kind of take care of it, right? I mean, you don't have any servers here. I provision a namespace and I don't know where those servers are. If one goes down, they just fix it. So on-premise, I don't think they've done a really good job with the tooling of being able to give you, here's the abstraction. I want to be able to program to it the same way. But on-premise, I have some different needs, right? Like you said, I need to be able to find that server that's not participating in the node. Now, there should be some of the PowerShell commandlets. It's been a while since I've looked at them. We should be able to go through and find all the servers in the farm. But I can't remember the level of detail that they give you that in terms of the status and those sorts of things. But I want to say they've got a notion of the heartbeats going on, but I may be confusing it between the different versions. All right. Well, thank you very much. Enjoy the rest of the show.